Graeme, we're grateful to have you here today. Please go ahead and share the content. Thank you.
Okay, welcome, and we're going to skip this information about me and just carry on with the presentation here. So this presentation is intended to be a very, very quick overview of Microsoft SQL Server, as well as an introduction to some of the availability options that are present within the SQL Server, both on-prem and in Azure. So we'll have an opportunity to look at several different options as we go through here. We're going to start just talking about versions. SQL Server's been around for a long time. When we actually take a look at this, it identifies SQL Server version 1 is coming out in 1989. SQL Server's versions between 1 and SQL Server 6.5 were binary compatible with Sybase. So fundamentally, Microsoft actually licensed the core code for Sybase and actually built on top of that. They had a much better GUI set of admin tools than Sybase did, but nonetheless. When we go to SQL Server 7, Microsoft actually changed some of the fundamental underlying structures here, specifically the way that data was actually stored. We went from a 2K to an 8K data page and things like that. And so we ceased being binary compatible with Sybase. As you go up here through SQL Server 2000, 2005, SQL Server 2005 sees the introduction of a different security paradigm, including things like hiding all of the system tables, that is the database metadata and server metadata, goes through and actually introduces database mirroring amongst servers, introduces XML support. And so SQL Server 2005 is fundamentally seen to be the first of the modern implementations of the SQL Server product. And by and large, I think is still the oldest version that you can actually have backward compatibility to in terms of moving database and stuff like that. If you have a database from something prior to SQL Server 2005, you can't import those into SQL Server without doing a couple of steps first. As you go through SQL Servers 2002, 2008, 2008 R2, we see a number of incremental changes to the SQL Server. The next version where we have a really massive change is SQL Server 2014. SQL Server 2012 introduced column store indexes. And that's a different way to physically store your data, which is potentially capable of achieving rates of compression that are way way out of the capabilities of a row store table. So you have two different types of tables in SQL Server. You have column store tables and you have row store tables, and the compression capabilities on the two types of tables are very, very different. SQL Server 2014 introduces in-memory, what Microsoft refers to as in-memory processing. Personally, when I see in-memory processing, I think that's weird because all processing is in memory, but nonetheless, that's a marketing speak. And what you'll actually find is that what we're talking about is a new transaction processing model. Okay, the standard transaction processing model with regard to row tables, which are the standard tables still, even in SQL Server 2019 and even in SQL Server in Azure, row tables are the standard default, and transaction processing uses locking behaviors and stuff like that. We use a pessimistic locking model. If, however, you have column store tables and in-memory processing, your transaction processing can move from a pessimistic locking model to an optimistic locking model. The optimistic locking model makes the tacit assumption that there will very seldom be contention for data, and therefore we don't bother locking the data. We go through, process the transactions, and then when we're finished, we have the opportunity to go back and validate to determine whether or not that transaction completed successfully, or whether a conflict has actually occurred. If a conflict occurred, we roll back one of the transactions in its entirety. So Microsoft claims that you can get up to a 30 times increase in transactional throughput provided that you are using column store indexes in conjunction with in-memory transaction processing, this new optimistic locking model. However, clearly that transaction processing model is not appropriate for situations where you are highly likely to have data contention. Right? So if I have a retail database and I have all sorts of customers coming in and actually doing purchasing through our web services and or salespeople going in and actually processing transactions associated with sales simultaneously, we have a very, very high likelihood of contention for data. And with a high likelihood of contention for data, we've got to use the standard transaction processing model because the optimistic processing model is likely to generate some real problems. So you have two models. Your developers have to understand under which circumstances to use which of the two models because they can be used simultaneously against the same database, just not against the same tables. Okay. SQL Server 2016, we have a number of new features in terms of scalability, things like that that are actually introduced. SQL Server 2017 is the next milestone version. SQL Server 2017 introduces, firstly, the ability to run SQL Server on top of Linux. They've taken the SQL Server database code and ported it for Linux. Microsoft has 3 supported Linux distributions: Ubuntu, Red Hat, and SUSE Enterprise. Right? You can, however, actually obtain the binaries and actually deploy the binaries to any distribution of Linux if you feel like it. So that is the one, and quite frankly, the single most important of the changes introduced in SQL Server 2017. Secondarily, SQL Server 2017 introduces automated plan regression. That is, the server monitors itself, and there are a certain number of actions that can be taken by the server when performance is being degraded. So this internal self-monitoring capability and performance enhancement, or not enhancement, but ability to actually respond to performance degradation is actually built into SQL Server 2017. SQL Server 2019 actually introduces additional capabilities on top of that. Now, all of these are the on-prem implementations of SQL Server, right? You obtain your licensing, you obtain the installation media, and you install SQL Server into a physical machine on-prem, into a virtual machine in your local data center, or into a virtual machine in Azure. There is no difference in terms of the executable code between a virtual machine on-prem running an SQL Server and a virtual machine in Azure running an SQL Server instance. It's identical. There is no feature differentiation. And assuming you have a site-to-site VPN and therefore the ability to join your Azure virtual machines to your on-prem domain, and or you have ExpressRoute, and again, the ability to route IP to IP between your Azure virtual machines and your on-prem, you can literally have virtual machines running in Azure with full versions of SQL Server with Windows-based authentication and all the features, functions, and capabilities of the SQL Server on-prem. Now, Azure has an SQL Server instance. The Azure SQL Server instance significantly lags behind in terms of features, functions, capabilities, right? Most of the reason for that is you just don't have access. So when you actually take a look at the Azure instance of SQL Server, the Azure instance of SQL Server supports only a subset of the functionality of the on-prem implementation, but by and large, the absence of those functionalities is compensated for by other cloud services. So the Azure instance of SQL Server has no agent, but you can actually create elastic database jobs, so maybe you can work around that. So there are workarounds for many of these missing capabilities. When you take a look at Azure, Azure was originally, I believe, based upon SQL Server 2012, but Azure's instance of SQL Server is what they refer to as evergreen. More correctly, what we would actually identify with that is that Microsoft applies the updates to Azure as soon as those updates are available, as frequently as every 6 weeks. So in terms of stability, your on-prem instances of SQL Server, you patch them, you have control. With an Azure instance, you don't patch, Microsoft does. And they patch in the background, and you're just going to get whatever the heck they give you. You have no influence or control over the version of SQL Server that you're actually getting there. You're just getting whatever they're actually publishing. Okay. So if I can find my mouse. Come on, mouse, where are you? Ah, that's why. Sorry. I'm running off of multiple computers here and I got confused. Okay, so when you actually deploy an instance of SQL Server, one of the things you're going to be able to do is determine which version of the SQL Server you actually want, or which edition of the SQL Server you want. Again, this is for on-prem. You have the Enterprise Edition. The Enterprise Edition is the flagship version of SQL Server, and it encompasses 100% of the features, capabilities, and functions that SQL Server actually exhibits. So if I want to do database mirroring with multiple read-only with automated failover, that's available in the Enterprise Edition, not available in any of the lower editions. The ability to actually set up an availability group with read-only replicas and redirect to read-only replicas, etc. All those capabilities are available in the Enterprise Edition. So there are a bunch of features that are stripped out in the Standard Edition. However, the Standard Edition has a much lower cost. So what you need to do is evaluate the feature set that you intend to use in your deployment. And if none of the features you intend to use are absent from the Standard Edition, you can deploy the Standard Edition, right? It's a really straightforward process to make that determination. Unfortunately, sometimes the requirements change, and that can actually be problematic. You have the Developer Edition. The Developer Edition is free. You can literally just download it and install it. It used to be incorporated into Visual Studio, but then again, Visual Studio is also available to be downloaded free, right? So the Developer Edition, however, has an identical feature set with the Enterprise Edition. The only limitation is the Developer Edition cannot be used in a production environment. That would be a violation, right? Since the Developer Edition has an identical feature set to the Enterprise Edition when installed on a server, if you install the Developer Edition on your workstation, you get a bunch of features that are disabled. But if you put it on a server, you get 100% feature compatibility with the Enterprise Edition. Why? Because if the developer can be fooled into accidentally using a feature that is only in the Enterprise Edition, you got to pay for the Enterprise Edition when you deploy that, right? We have the Express Edition, which is literally free. The Express Edition of SQL Server is not only free, but it is also able to be distributed freely. The net result is there are a large number of third-party products which actually incorporate the Express Edition and automatically deploy the Express Edition during the installation. There's also something called the WID, the Windows Internal Database. The Windows Internal Database, or WID, is built into Windows Server, the operating system. So if I go into a Windows server and I say, I want this server to be a WSUS, a Windows Update Server, WSUS requires a database. I can either install the SQL Server client, connect across the wire to a production level SQL Server and use that as the database to backend my update service, or I can just use the WID, the Windows Internal Database. And under certain circumstances, Microsoft has done some interesting things with the Windows Internal Database, which is ostensibly the Express Edition built into the server. Specifically, if I'm setting up Federation services and I use the WID, you can replicate, I think it's up to 6 servers copy of the WID in order to make the WID highly available, which is kind of weird, right? Normally the Express Edition is a single server implementation, but let's get away from that. There's a compact edition of the SQL Server. The compact edition of the SQL Server was originally designed to run on ARM-based devices, right? Actually, we used to have a version of Windows operating system called Windows CE Compact Edition, and that's where it was originally designed to work. So years and years and years ago, I had a really, really cool tool. It was a combination cell phone and mini tablet thing running Windows CE. So I could actually run Outlook and Word and things like that on my little tiny tablet. These things are commonplace now, but at the time, this was really, really cool. And I could actually install the compact edition of SQL Server on there, and I could do things like replicate from local tables on my local handheld device to a production level server via an HTTP gateway. So there were some interesting things you can actually do with the compact edition in order to actually build out custom application services. This would potentially be used for something like if I had a parcel delivery service and the delivery trucks are carrying around tablets, right? We could actually replicate data into the tables on the tablet, have that actually be modified, disconnected, and then when the driver came back, drop the tablet into a docking station and then replicate all the changes from the tablet up. Nowadays, everybody's got, Wi-Fi, or not Wi-Fi, got cell phone, right? And so we can do this, we can actually have real time, but back in the day, you didn't have that, right? That data access was not ubiquitous. So we actually have the compact edition, and we have the business intelligence edition, and then we have this one here, the Azure SQL Server database. There are two variants of the Azure SQL Server database. There is the standard platform as a service offering, and then there is something called Azure SQL Managed Instance, which provides you with a set of features which are closer to an on-prem implementation, but not quite, right? So if you need an SQL Server agent, et cetera, there is an option to do that in a platform as a service offering, and we'll deal with that later. Again, SQL Server 2017 and SQL Server 2019 come in a Linux build, and the supported operating systems are, the Linux distributions are Red Hat Enterprise, SUSE Linux Enterprise, and Ubuntu Server. Although, again, you could technically obtain the binaries and actually get it to run on most versions of Linux. Docker. Many brand new applications are actually coming designed to run in Docker containers. And initially, Microsoft joined the Docker project, right? They had a container project, they joined the Docker project, they ported Docker to Windows. So the container implementation on top of Windows is literally Docker. And originally, they actually had a Docker container running a core installation of Windows Server with SQL Server actually running in a Windows container. Currently, however, if you go up and actually search for that on Microsoft's MCR, that is the container repository, you won't find that anymore. Microsoft has withdrawn the SQL Server running on Windows as a container platform, and they've replaced that with SQL Server running in Linux as a container platform. I'm assuming that's because either A, it didn't have the stability, or B, most people who are running container platforms are doing so based upon primarily Linux-based operating systems. So I'm not sure why they withdrew the SQL Server on Windows container image, but you have the production level SQL container image, which is SQL Server running in a Linux-based container. I believe the container is Ubuntu. Okay. So that is the only supported implementation of a container with SQL Server, although there is a developer edition, which I think actually runs Windows Core with Windows SQL Server in it. Okay, so there's that. During the installation of the SQL Server, you have a number of options with regard to features and functions capabilities that you can choose to install. You have the database engine. You can actually have multiple instances of the database engine, up to a maximum of 50 instances of the database engine per physical or virtual machine. You have analysis services. Analysis services has a new name up in Azure, but basically, when I install analysis services, I connect the analysis services to data sources, usually SQL Server, but doesn't have to be, could be any data source. And I build what is referred to as a data cube. A data cube is a multi-dimensional data structure in which I pre-aggregate data. I then take those data cubes and I apply data mining models to the data cubes in order to glean intelligence from the data. Right, and there is another query language called MDX that is actually used against the multi-dimensional data stores and stuff like that. So that's analysis services. It's been around for a long time. We have integration services. SQL Server Integration Services, or SSIS, is a set of tools to move data from one location to another. So if I have an Oracle database and I want to get the data out of the Oracle database into the SQL Server, I can go through and I can actually set up an SSIS job and execute that, and will connect to the source database, connect to the destination database, and actually perform an ETL extract, transform, and load operation. And these can be as complex as required, and there's all kinds of things you can actually do. In order to build an ETL job, you go into Visual Studio, and you have a series of tools built into Visual Studio based upon the client tools that come from Microsoft associated with Visual Studio. We then have reporting services. Reporting services is a web services solution whereby you publish RDL objects to the web server. A client would then connect in, select the RDL object or report that they wanted to actually view, and the web server would communicate with a reporting server, and the reporting server would go into the relational database, extract the data, format the data, and then return it to the user. So user self-service access to reports based upon the information that is actually inside the SQL Server database. That data could be live, and you can do funky and interesting things like schedule delivery of reports automatically. The user can do self-service scheduling of reports, stuff like that. You have master data services. Master data services is a capability where if you are holding multiple copies of the same data distributed across multiple servers, you can actually identify which one is authoritative and validate whether or not the other servers have actually deviated from that. You also have DQS, data quality services, associated with that as well. You have Stream Insight, the ability to dip into data as it's actually moving from server to server and have a look at that. You have full text search. Full text search is an augmentation to SQL Server's internal indexing. SQL Server's internal indexing is fantastic at discrete values. So I have a column of first names, a column of last names, a column of numbers, right? SQL Server is fantastic at indexing those, searching and locating that data really efficiently. If I have a column of random text, let's say this is a public library database and have a column which is the synopsis of the book, SQL Server's internal indexing can't handle that. Enter full text indexing. Full text indexing was taken from IIS, the web server. It is literally the web server's search service. You then plug it into your SQL Server. You tell it, hey, I want you to actually build a keyword list off of this column right here. The IIS search service reads the column and builds a keyword list mapped to the primary keys of the table. You must have primary keys on the table in order to be able to do this. And what then happens is when I want to actually use that column for search operations, there are specialized queries that I use, full text, free text, etc. Queries that I actually use, sorry, contains is the keyword. And what will actually happen is those commands, instead of submitting the query to the SQL Server, will go off and actually pass that over to the search service. The search service will look through its pre-built list of words, its word list, identify where those search terms are actually present, return a key list to the SQL Server. The SQL Server can then actually go and actually return those records to the system. So this full text search is a very, very effective augmentation to SQL Server's internal indexing when you're actually dealing with large blocks of unstructured data. SQL Server includes replication, and so I can actually have replication between multiple servers, and we'll talk about that in a little bit more detail later. We have Power Pivot. So the ability to do pivot tables in Excel has been available for quite a long time. Power Pivot is taking the ability to run pivot operations and moving it from the application, the client, and having it done on the server. So the server performs the pivot and simply returns the data already pivoted for me. We have Power View and Polybase. Polybase in this particular case is the ability to configure connectivity between your server and NoSQL Server databases like Hadoop. You can then submit a query to the SQL Server in a language that looks very, very similar to Transact SQL. And the server will then go off to the NoSQL server, refactor the query such that it is intelligible to the NoSQL server, get a result set back, organize the results, and actually return it to me. So this significantly simplifies interactions with NoSQL implementations. We then have machine learning solutions, including R and Python, that are actually available to be used inside of the SQL Server. So a number of different features that are available inside the SQL Server. If we take a look at an on-prem implementation of SQL Server, we have some scalability capabilities here. First of all, instances per computer. You can have up to 50 instances of SQL Server running on the same computer at the same time. Doesn't matter whether it's physical or virtual, but of course you need enough resources for each of those. Each instance of SQL Server has its own security implementation, and hence, from a security perspective, it's completely isolated. It is further isolated in terms of its resource. So the memory, CPU time, disk storage, and et cetera, that are allocated to one instance are completely unavailable to any other instance. So if I have an application which is multi-tenant, I could assign each tenant a unique instance, and their instance would, from a security and resource perspective, be completely isolated from any other instance. So that's one of the capabilities. You can also have 50 instances running in a failover cluster. So in a failover cluster, you can have up to 64 nodes, and you can have 50 instances running within the failover cluster. So that is in the cluster. It does, however, depend on where you're putting the databases, right? So if you're using SAN storage, only 25 instances per SMB storage, you can actually get up to 50 instances per cluster. In this particular case, SMB storage specifically refers to a scale-out file server. Databases per SQL Server. You can theoretically have 32,000 databases per server, that is per instance, 50 instances times 32,000 databases. That, however, is a theoretical number based upon simply the length of the database ID field, right? So database size. A database is able to actually have 32,000 files assigned to it. Each transaction log file has a maximum size of 2 terabytes. Each data file has a maximum size of, I think it's 16 terabytes. So when you do the math, the maximum size of an individual database is 524,000 terabytes, theoretical, again. That's an individual database. You have 32,000 of these per server, theoretically. Yes. Maximum compute capacity resources. So when you install the Enterprise Edition of SQL Server onto the Data Center Edition of Windows Server, you can access the complete resource availability in terms of physical RAM and processors of the underlying host. So in this particular case, the underlying host can have up to 64 sockets, that is physical CPUs. Each CPU can have X number of cores, and so you can actually end up with, I think, one of the documentation says 640, so 10 cores per physical CPU. Other documentation says only 360, something like that. But anyway, however many physical CPUs and cores you can actually expose to the host, SQL Server Enterprise Edition can take advantage. The Standard Edition has limitations as to how many cores and how much RAM it can actually use. But the Enterprise Edition running on the Data Center Edition would be able to do that. And in terms of RAM, the Data Center Edition of the Windows Server has the ability to address up to 24 terabytes of RAM. The Enterprise Edition of SQL Server similarly has the ability to do that. And there's some advanced features like the buffer pool extension so that SQL Server can handle its own swapping, right? The operating system swapping SQL Server is bad. SQL Server swapping itself works a little better. Okay, so, sorry, I keep losing my mouse in the whiteness here. Okay, so client tools. When we take a look at client tools, the flagship client tool for SQL Server is SQL Server Management Studio, SSMS. It is a free download from Microsoft. Previously, the SQL Server Management Studio was delivered on the server installation media. It's no longer included on the server installation media. You have to download it, but not only do you have to download it yourself, you have to update the silly thing yourself. You have to download the new version and run the installer for the new version, which is a little annoying, but oh well. The SQL Server Management Studio, however, is only available for Windows. You have SSDT. SSDT, or the SQL Server Data Tools, is a set of plugins to Visual Studio, and those plugins to Visual Studio are available only on Visual Studio, and since Visual Studio is available only on Windows, that's the only platform. So when I want to go in and build RDL objects from reporting services, when I want to go in and build SSIS packages and etc., I need to do that through Visual Studio, and I need a Windows desktop with Visual Studio installed to install these extensions in order to be able to use that. Most of the other tools, however, are cross-platform at this point. SQL Server CMD, no longer built into the server. You have to download it and install it, and it's available to be installed on both Windows and Linux and Mac. The SQL PowerShell. There was an SQL PowerShell module called SQLPL that used to be included with the SQL Server installation. You could then install that on your workstation. Now there is a SQL module called SQL Server that is available to be installed via OneGet. I don't know if you've actually played with OneGet. OneGet is a solution where you connect to a repository, and Microsoft has their own repository, and you use PowerShell to install software on a computer. So when I want to install the SQL PowerShell module, I have to configure my computer to communicate with Microsoft's repository, and then I can execute PowerShell commands to retrieve the software and install it from the repository on my server and or on my workstation, because the PowerShell doesn't come built in anymore, either to the SQL Server Management Studio or to the SQL Server. You got to download that and install it, and again, that is available. PowerShell itself is available to be run on Windows, Mac, and Linux. Azure Data Studio. Azure Data Studio is a cross-platform database management solution. It certainly doesn't have the feature set that you actually get when you're actually using SQL Server Management Studio. So most database administrators are probably going to stick with Management Studio, which means if I'm managing Linux-based instances of SQL Server, I got to have a Windows workstation to actually manage them. However, this tool as a cross-platform tool allows me to do many of the things that I need to do with SQL Server, and it supports Jupyter Notebooks. And Jupyter Notebooks are actually quite an interesting concept here. Jupyter Notebooks were actually developed in conjunction with machine learning scenarios, and I can actually build a Jupyter Notebook with a bunch of queries embedded into it, send it to you, you open up the notebook, execute the queries, embed the results into the notebook, and send it back to me so I can actually see what's going on in your system. So some very interesting things are being done with Azure Data Studio. We then have Visual Studio Code. Visual Studio Code is not Visual Studio, it's something else, but it is cross-platform. So Windows, Linux, Mac OS. And what you do is you install Visual Studio Code, and then you actually pull a plugin or an extension to actually manage and work with SQL Server, right? There is Azure Data Factory. This is a cloud service, right? So you manage Azure Data Factory using the web browser, and you can actually configure movements of data using that. There's also a series of tools identified with the SQL Server Migration Assistant. So there is an SQL Server Migration Assistant to move from one version of SQL Server to another, so from on-prem to Azure, but there are also migration assistants to go from Oracle to SQL Server, DB2 to SQL Server, Access to SQL Server, and et cetera. So there's a whole bunch of these migration assistants that are available that you can actually use depending on what your source and destination databases are. And for those of you who are posting comments into the chat session there, I'll try to get to those when we finish, but I am under a little time crunch here because I've got to go. I was teaching up till 12 o'clock, and I've got to go back to teaching at 1 o'clock. So,
Graeme?
Yeah.
Pardon the quick interruption. A couple of those comments are regarding some background, like maybe typing or clicking noise that seems to be coming. I don't know if that's from your microphone or if there's anything you can do.
Yeah,
I have no idea what it might be.
That's actually the Logitech headset I'm using for this.
Gotcha.
Right. My normal headset that I actually use when I'm teaching is connected to a different computer.
Okay.
And so
Perfect.
I'm using
we
a
can
Logitech.
still hear you.
Yeah,
we can still hear you. Just thought if it was something easy, we could eliminate. No worries.
No,
Thank you.
every time I move, the wire causes a crackle in the wire actually causes a noise in the headset.
Gotcha.
And so
No
if
worries.
I hold really, really still, right? But I talk like an Italian. I have my hands moving. You just can't see it.
Perfect. No worries. Thank you.
Okay, so I don't know if I hold that. Okay, so in this particular case, you have the SQL Server Migration Assistants, plural, and several. One of those is very, very specifically designed for taking database from on-prem and actually deploying it to Azure. However, there are other variants of that for different sources, depending on what you're actually going from and going to. Okay, so new features. I already covered some of this. I'm starting at SQL Server 2014, in-memory online transaction processing, and the buffer pool extension. The buffer pool extension is basically teaching SQL Server how to swap its own memory instead of allowing the operating system to do it, because the operating system doesn't know what SQL Server is doing with its memory space. So there's that. SQL Server 2016, we have temporal tables. Temporal tables are interesting because they keep track of every time a record changes, and I can go back and actually look and ask, what did this table look like at this point in time, and or show me all the versions of this particular record, stuff like that. Always encrypted. This is a client-side encryption mechanism whereby we encrypt the values for a specific column, send them already encrypted to the server stores them encrypted and cannot normally decrypt them. We have dynamic data masking. The idea here is we're not encrypting the data, but when somebody queries for a credit card number, they don't get the whole credit card number, they just get a part of it. When they query for an email address, they don't get the whole email address, they just get a part of it. So I can dynamically, in the result set, swap out sensitive data for masked versions of that data. We get row-level security, the ability to go in and actually have different security on different subsets of the records. Inside of a table, we have the ability to actually set up a stretch database. Stretch database is interesting. You have a database on-prem, and you have a database in Azure. You take specific tables and you hold some data on-prem, and the rest of the data you push out to Azure. Gives you fundamentally unlimited scalability, I guess, to your table data structure. And what you need to do is actually define where that boundary is. What data should reside inside the tables on-prem and what data should be actually migrated into Azure. And you have to remember the Azure tables don't have indexing and stuff like that. So access to that data is going to be delayed, but I could actually, for example, have the current 13 months in my on-prem server, and anything archival further back than 13 months, I could keep it in the same table, but physically have it up in an Azure SQL Server instance. You just want to watch your costs on that because that can be very expensive. SQL Server 2017, automatic database tuning, Linux support, SQL Server machine learning services, including Python and R services. SQL Server 2016 had that, but just had R. The Python was the new one there. SQL Server 2019, always encrypted secure enclaves. That is the ability for the server to decrypt that which the client has encrypted, which in SQL Server 2016 and 2017 was not available. 2019 can now do that. Data discovery and classification. So if you are subject to various different legal requirements with your data, you can actually apply classifications to your data and hence have appropriate labeling of sensitive data. That's a very, very useful feature, and that works in conjunction with some of your Azure services associated with that. Okay, so high availability options. SQL Server on-prem supports availability groups. Availability groups are built on top of database mirroring. So database mirroring was introduced on SQL Server 2005. Database mirroring allowed you to maintain a primary and a mirror database, and you had a third server as a witness. What would then happen is in the .NET Framework connector object, you would embed the identity of the primary and the identity of the mirror. Your client would then connect to the primary, but if the primary became unavailable, The mirror and the witness server would determine that the primary was unavailable, bring the mirror copy online, and the client, because it already knew where the mirror was, would be able to connect to the mirror and continue actually accessing the database. And since that was normally configured for synchronous replication, that is, the primary could not report a transaction as committed until the mirror committed it, you would be able to actually have transparent failover there. The Enterprise Edition supported the witness server. The Standard Edition didn't support the witness, and therefore you didn't have automated failover. The fundamental problem with mirroring, however, was, or is, that the client has to be aware. The client has to know where the primary and the mirror are, and hence anything that was not a .NET Framework-based client couldn't use that. So enter availability groups. Availability groups use database mirroring, but an availability group runs in a cluster. And you have a cluster service that anchors access to the availability group. So the client, instead of connecting to the server in the cluster, which is actually holding the database, connects to the cluster service, which is the point. The cluster service anchor point redirects the client's read-write requests to the read-write replica. There's only one. You have to 9 replicas, but only one can be read-write, and will automatically be able to, based on session parameters, redirect read-only requests to a read-only replica. So you can have up to 9 replicas and one read-write only ever, but you can have multiple read-writes, and the cluster can redirect the clients to the read-writes, to the read-onlys, if their client session identifies that as a read-only session. So that's availability groups, and that's available in the enterprise, and a simplified version is available in the standard edition of the Windows Server. We have failover clustering. Notice the always on, that's a marketing label, right? So we have failover clustering. We can actually create a clustered instance of SQL Server, and that makes it highly available. That's available both in the enterprise and the standard edition. The standard edition, however, has a limit on the number of nodes in the cluster we can actually use. We have database replication. All versions of SQL Server, down to and including the mobile version of SQL Server, can actually do replication in one form or another. You have scale out server federation. Scale out server federation is a scenario where I have a database and the load that the database generates is so large that a single physical server can't handle it, right? Any one database is accessible only off a single physical server under normal circumstances. So what you do is you design your database so that you can break it into chunks, and you distribute the chunks as databases to different servers, and then you actually use your middle tier to stitch it all together to make it look like it's one database, when in actuality it's 3 or 4 databases distributed across 3 or 4 servers. Okay. And in the cloud, we have something called a shard mapper, which will actually facilitate federation in the cloud, which is actually pretty cool. You have a high availability solution called log shipping. Log shipping is literally, I take a backup of my database and I restore it onto another server. I then take transaction log backups, and every time I take a transaction log backup, I restore it on the log ship server. Hence, the log ship server is only one transaction log backup behind my production server. If therefore anything ever goes wrong with my production server, I simply grab the last backup of the transaction log from the production server, restore it on my warm standby server, my standby server, bring that server online, reconnect the clients to it, and we can be back up and running in a very, very short period of time, right? So log shipping is that's available on every version of SQL Server. There's also host clustering. Host clustering is not high availability for SQL Server itself, but high availability for the virtual machine that SQL Server is running in, but that's still high availability, right? So when we take a look at always on availability groups, this is the most important of the high availability solutions that we actually have. When you actually take a look at this, you have a single primary replica, which is read-write. You only ever have one per cluster. And you can have up to 8 secondaries, or a total of 9 of those. In Server 2016, you can have 2 read-only. One read-write, and you could have 2 read-onlys. In Server 2017, you could have 3 read-onlys, and in Server 2019, you can have 4 read-onlys. And the cluster service will dynamically redirect clients to either the read-write copy of the database or a read-only copy of the database in order to distribute load. So your read load is redistributed across the read-onlys, and your write load is actually happening off a single server, and you have synchronous database mirroring being used in order to maintain the additional copies. It is technically possible to have asynchronous, but it is limited in terms of what you can actually do with that. So you have synchronous commit mode, which is the default. You have automatic failure, as well as the ability to manually fail over this. There's also an asynchronous commit mode, but that means that you could have a loss of data. We then have a failover cluster implementation. With a failover cluster, I have between 2 and 64 nodes participating in the cluster. For each of the 50 potential instances that I can have running in the cluster, I physically sit down at every single node in the cluster, and I do an install of the SQL Server on the first one, and then I do an additional node install on every other node in the cluster. The databases have to be on highly available storage, such that every node in the cluster has access to the databases, and the cluster will control which node singular in the cluster is running that SQL Server at any point in time. So only one node in the cluster is running an instance, but we can have up to 50 instances, and hence, if you have a large number of servers participating in the cluster, let's say I have 8 servers in the cluster and I have 50 instances of SQL Server, you can then redistribute those instances across the remaining servers, even though an individual instance can only run on one server at a time, one node at a time. So when we take a look at this again, with SAN storage, you can have 25 instances running in the cluster. With SMB storage, which is a scale-out file server solution, 50 nodes in the cluster. You can also combine SQL Server clustering amongst guest operating systems with host clustering. So I have a cluster of Hyper-V hosts or a VMware HA solution in my data center. I'm running SQL Server in virtual machines on top of that highly available Hyper-V cluster or VMware HA solution, and I set up data amongst individual virtual machines, so you can actually double up on the high availability in order to actually have multiple layers of redundancy built in there. When we talk about replication, SQL Server supports a number of forms of replication. Please note, all forms of replication will introduce latency, right? That is, at any individual point in time, the versions of the database will potentially be slightly different. But provided that your application can actually handle that, you can actually have transactional replications. Transactional replication, we monitor the transaction log. Each time a transaction occurs against data which is published in an article, we extract that, put it into a queue, and have that data processed against all the other replicas. You can have multiple replicas if you want, right? So we have transactional replication, we have merge replication. Merge replication requires some physical changes to the databases so that we can actually identify versions of records. So you need global identifiers on each record, you need version numbers on each record, at which point any server can make any change to any record. We will then replicate that out, and replication conflicts would cause problems, but you can actually have different servers making changes to the data simultaneously. You have snapshot replication, where basically I take a snapshot of the data and I publish it periodically. So once a week, I'm going to take a snapshot of the data and push that out to the other servers. The other servers will then be static from that point. You have what is referred to as peer-to-peer. Peer-to-peer would be a replication scenario where, for example, I took 2 servers and I had 2 different replication configurations, where one is a subscriber to the replication of the other, and the other is a subscriber to the replication of the first, and we can actually do that. So that's peer-to-peer replication, bidirectional. We also have updatable subscribers, so the ability to actually make modifications on the subscribing servers. Please note, when you actually take a look at subscribers here, the servers that are participating in replication don't all have to be Microsoft SQL servers. So I can create an article on an SQL server where the data is sitting on an Oracle server, and I pull the data in and replicate it out using a Microsoft SQL Server. Alternatively, I can have an Oracle subscriber where the distribution server is logging into the Oracle server, and you can do this with a couple of other platforms as well, but Oracle's the one that comes up to mind first. So I can have an Oracle subscriber so that the distribution server connects across the wire to the server and actually pushes the changes out, right? So when you take a look at replication, replication can be done in a heterogeneous environment to a limited extent. So the source doesn't have to be an SQL Server, and the destination doesn't have to be an SQL Server. And under the heading of not an SQL Server, Azure SQL is in that category. Why? Because Azure SQL Server doesn't have an SQL Server agent, and therefore cannot directly participate in replication. But as a subscriber, where the distribution server is pushing the data to it, that actually works. So we have pull subscriptions, which are the default, push subscriptions, which allow you to have non-SQL or Azure subscribers. So that's replication. Do note, all replication has some kind of latency in between the time that a change occurs on one instance of SQL Server and the time that it shows up on the rest of the servers. The amount of latency is dependent on your networking configuration. SQL Server security features. I'm running out of time here, so I'm going to have to quick speed up. We can encrypt the communication between the SQL Server and the SQL Server client. That is done through TLS, also known as SSL. So I set up an SSL certificate or TLS certificate on my SQL Server. Once I've registered the TLS certificate on my SQL Server, I go to the client and I say, hey, let's use TLS. I also have a force flag that I can actually use to encrypt that. And that is built into the SQL Server client. Please note, when you deploy SQL Server, it doesn't magically get a TLS certificate. So somebody has to deliberately sit down at the server, obtain a TLS certificate, register it into the SQL Server for use before you can actually do this. So if you just deployed a brand new SQL Server, you have no encryption on the wire. That's bad. So all versions of SQL Server can actually do that. IPsec, this is not SQL Server, this is operating system level. I go into a set of group policies and I tell my computers, hey, every time somebody connects to port 1433, I want you to establish an IPsec tunnel first. And so we can actually have encrypted communication there, but that is operating system level, not SQL Server level. We have transparent data encryption or transparent database encryption. TDE goes in and encrypts every single data page belonging to the database. There's a set of encryption keys which are protected with a public-private key pair. So I go to the server, I load the public-private key pair into memory on the server. When I try to mount the database, the private key is used to access the symmetric key. And having the symmetric key in memory, I can now decrypt the data pages and hence mount the database. So that is available both on-prem and in Azure. We have column level encryption. This is internal to the SQL Server. I can go in and tell the SQL Server to actually encrypt a column of data. You also have always encrypted, which is also column level encryption. The difference between column encryption and always encrypted is call encryption, the keys are on the server. With always encrypted, the public and private key with which the symmetric key is protected is on the client. The server doesn't have a copy. Therefore, the server can't access the data. Only the client can. But it is client-side decryption. The client retrieves the symmetric key. The client decrypts the symmetric key. The client decrypts the data with the symmetric key. The server has no access to the encrypted data, except Server 2019, where we have the secure enclave. You take the public and private keys from the client, you put it into the secure enclave, little virtual machine that runs effectively on the server, and then the server can actually decrypt its own data in the secure enclave, right? We also have encrypted backups, so we can not only encrypt the database, we can actually encrypt the backups, and that's available on Enterprise and Standard. When we actually take a look at further security features, we have server audit. We can actually set up auditing in SQL Server. We have data classification and auditing. Again, that's new to SQL Server 2019. We have dynamic data masking, where the server can automatically obfuscate data when somebody who has permissions to access the data but doesn't have permissions to see it asks for it. So email addresses, any information that you find identified as sensitive, you can actually flag it, and the server will just return a obfuscated value instead of the real value for credit card numbers, things like that. You also have row-level security, the ability to go in and define permissions on sets of records inside of an individual table. Azure database offerings. So we're moving now to the cloud in 3 minutes or less. So you have the Azure database. Again, the Azure database is a platform as a service offering. It has only a subset of the functionalities of the production server. You have the ability to install SQL Server into a virtual machine. If you install SQL Server into a virtual machine in Azure, you have 100% of the features. And if you have network connectivity via a site-to-site VPN or ExpressRoute, you have that Azure virtual machine, a member of your domain, and access the SQL Server identically to a normal SQL Server. You actually have also got, it should be here. Actually, it should be in there. I don't see it in there. You also have an Azure managed instance. An Azure managed instance runs as a platform as a service offering in Azure, has an SQL Server agent, has feature set that is closer to the on-prem feature set, but still some specific limitations. That version is designed to provide you with a better opportunity to lift and shift databases from on-prem to Azure, where you have a database which has features which are not supported in the Azure instance. You might be able to get that to run in an Azure managed instance, and if you can't get it to run there, you will absolutely be able to get it to run in a virtual machine. I don't know why that's not on the slide. You have Azure Synapse, which is SQL Server Analysis Services in Azure. You have Azure HD Insight, which is a Hadoop implementation in Azure, which is a NoSQL solution. We have Cosmos DB, which is MongoDB, an open source database solution. We have other open source database solutions. So we have MySQL, Postgres, MariaDB. MariaDB is a fork of MySQL. So you have a number of open source database solutions. You also have Azure Data Lake. You also in storage have table storage. So you can just create a storage account and have table storage in a storage account, but that's not really a database per se. So there are a number of offerings that we actually have in Azure here. In terms of high availability, when you actually spin up an instance of SQL Server in Azure, that is the platform as a service offering, what you're going to find is when your application tries to connect in, they're going to actually hit this gateway ring, and your encrypted communications will be terminated there. The communications will be forwarded to the instance. The instance is using highly available storage, so is effectively a failover cluster instance. And if anything happens to the underlying system, we will just simply redirect. We will take that, move it to a new node, and bring it online. A little bit of weirdness here because although you have an instance, each database has its own availability solution associated with it. So slightly different than on-prem, but fundamentally, your standard deployment in Azure is a failover cluster. And you can also, if you're using the premium or business critical service tiers, so it's how much you pay that determines this, you end up with an availability group with a single read-write replica and potentially multiple read-only replicas in Azure. But the cool thing is you just simply say, I want to pay lots and lots of money for this business critical, and you end up with an availability group without you having to build any of this. And further, one of your read-write replicas can actually be in a different data set. And hence you have geographic failover in Azure with that. Okay.